Hey guys, it's @Revolucy here, and today we'll be taking a look at a Form 4 Chapter 5 subtopic, which is total internal reflection. This comes from the chapter called Light. Now, to understand total internal reflection, or as in its short form TIR, first we need to look at what is refraction. Okay, this is also part of the Chapter 5, which is light. So, what is refraction in the context of light? Well, when light travels between two mediums of different optical densities, the direction and speed of light changes. So the most important one is speed, okay? Speed. The speed influences the direction in which the light moves, okay? So for example, let me use these two drawings here. This is a less dense medium and this is a more dense medium. So when a light ray passes through here, it will take less time to go through the same distance. Okay, let's just assume that this distance and this distance is the same. Okay, the light will take a less time to go through a less dense medium because it only hits a few particles and it bounces off, so it's out very fast. But if you take it if you let it pass through a dense medium, it will take a long time to reach the other side. This is why we say that the speed of light is higher in a medium that is less dense. Okay, because this is distance. Okay, they're constant, and when we record the time taken for the light ray to get passed through this distance, speed equals to distance over time, so we can get the speed. Okay, so in a denser medium, the speed of light will be lower. In a less dense medium, it will be higher, and in a vacuum, it will be at the maximum. Okay, so this changes in speed of light is what causes refraction, really. So we have here light rays traveling from a denser medium to a less dense medium. So a denser medium, that means the speed of light is lower, and the less dense medium, that means the speed of light increases. So here in the glass block, which has higher density, the velocity of light will be lower. Okay, and in the air, where it is lower density, the velocity of light will be higher. So this change in velocity from slower to faster causes the light ray to bend away from the normal. This is what we call the normal line. It is 90 degrees perpendicular to the plane, okay, the axis. So due to the increase in speed, it bends away from the normal. Okay, whereas in this example here, where the light ray is traveling from a less dense medium to a more dense medium, it bends towards the medium because its speed decreases. Okay, because the glass block is of higher density, so the speed of light will be lower. Okay, and down here the air speed of light is higher. Okay, we all see this in relative terms. Okay, it's very important, the word relative. We are comparing between these two mediums. Okay, by now you should understand why the light bends towards the normal or away from the normal. Okay, this is basically refraction. Okay, now off we go to the main part of today. Now, what is the textbook definition for total internal reflection and how it happens? Okay, so light, when moves from dense to less dense medium, is very important. Dense to less dense medium is one of the conditions. It moves away from the normal. Okay, I explained to you guys on why it moves away from the normal. Okay, so when the angle of incidence, okay, angle of incidence, which I represent with I, okay, look, angle of incidence, that means the first angle that you get when the light ray is incident onto the normal line. If you keep increasing the angle of incidence, the angle of refraction also will increase. Okay, That's basically it. So when the angle of refraction becomes 90, okay, as you can see here, when the angle of refraction becomes 90, okay, like in this small diagram, the angle of incidence at that time is called the critical angle. So critical angle is the incident angle in which the refracted angle is 90 degrees. Okay, this is very important. Okay, they usually will ask you the definition for critical angle, so you got to know that. So when the incident angle after this point increases more, if we increase the incident angle more than that, more than the critical angle, let's say the critical angle is 42 degrees. Okay, this is the normal critical angle for glass, and the incident angle was, let's say, 45 degrees, then you get a result like this, where total internal reflection occurs. So the incident and the reflected angle is always the same. It follows the Snell's law, okay? And now total internal reflection has occurred. And remember, these two angles will be the same, and both the incident angle and the reflected angle will be on the same plane. That's basically Snell's law. Okay, total internal reflection looks like this. Okay, now on to the final part, or I should call it the wrap up. Okay, so now you should try to recall the textbook definitions. They are asked frequently in essay and structured questions, okay? So you should slowly try to remember. Don't memorize everything at one shot, okay? Just understand it for now. You can memorize when the exam is like close if you are forgetful. If you're not forgetful, you can just try to remember now itself, because that saves time later. And you should remember about the main criteria or conditions for TIR to happen. Okay, this is very important. So light must travel from high dense medium to low dense medium. It must be a high dense medium to a low dense medium. Okay, it's very important. If this condition is not fulfilled, or any one of these conditions are not fulfilled actually, total internal reflection won't occur. So the next condition is the angle of incidence must exceed the critical angle. Okay, if it's not exceeding the critical angle, or it's not, refraction will still happen. So when it exceeds critical angle, only then total internal reflection will occur. So there are many applications for TIR in real life. Okay, so one is the periscope, we have the mirror periscope, and the glass prism periscope. So glass prism periscope is the better one, as it produces a sharper and brighter image. Okay, you should know this. And then we have the endoscope, which is used in medical applications. And then we have fiber optics, okay, Unify in Malaysia, very popular for high-speed data transfer. And then finally binoculars, to look at objects like birds far away. Okay, thank you guys for watching. Okay, please subscribe if you want more videos like this, and do comment below the subtopics that you guys particularly find difficult. I'll try my best to tackle them in a future video. Thank you guys for watching. Please rate, comment, and share and subscribe. Thank you guys. This is Ed Revolucy signing out.